bearing motor roll ring module. It's got the cover plate in place. They are tethered to it, and they are getting it ready to be taken out of the canister. It's protective housing to get it out to the work site. There you see the front connectors that will eventually be hooked up, that will allow the bearing motor roll ring module to do its job, passing power through. The next video that you see is the primary power connector, and this is the one that we are very, very concerned about. It takes all the 160 volt power from the solar array and passes it back to the batteries and the rest of the power system on board station. We had to do it during eclipse. That's why it's dark in the picture. We also put a lot of safety inhibits in place. Here you see the failed bearing motor roll ring module being removed from the beta gimbal assembly housing. You can see that Peggy has to maneuver it very carefully. She's lifting it up, out and away, and then she's going to position it in a safe location. Also in that picture you can see the base end of the electrical connector. This again is where the main power passes out of the solar array and into the bearing motor roll ring module. The next picture that you see is the new one being installed. We had a protective cap over the primary power connector that you see right there, and that helps us because if we did go into the sunlight with that protective cap on, we could continue working if we got everything else bolted in place. Again, this is the old boom being handed out from Peggy to Dan. This is after the new one has been installed, so we're in good shape now. We're just kind of cleaning up the work site. You can see the size of this thing as it's passing by. It's pretty big, it's heavy, but they did a great job handling it, getting it where it needed to go. Dan takes it out and he slides it back into the protective canister to bring it home. They'll do the same bolting process to get back, and here we have some video.
And just so you know, from our data down here, that motion is good. The currents and rates are good. Also, the 3 switches that popped open a couple months ago are now closed and staying closed, the primary backup and control. So we're looking good so far.
Excellent. Excellent. Outstanding. Good to hear.
Awesome work, you guys. And
isn't that cool?
Awesome work, you guys. And Peggy, just above you is...
actually, awesome work up to all the guys. Really. All the guys on the ground. It was a lot more work for them now. Yeah. Really appreciate it.
We copy the good words. Thanks a lot.
So that actually was the very exciting part of the spacewalk. At that point, the crew members were working on doing their inspection of the solar array alpha rotary joint, pulling covers off, looking at the state of the roll ring underneath, collecting samples to evaluate on the ground for further analysis. We were all very happy to see the solar array rotate the way it did. Now they'll be able to track power and as Quatsi mentioned, get it back where we need to be for all the international partner elements that are on their way up. And that's all I have.
Okay, great. Thanks, Keith. We'll take questions here in Houston, then go around to the other centers, and we'll start off with Mark.
Thank you, Mark Carreau from the Houston Chronicle. I have a couple of questions. The first one is, with the checkout complete, when will normal beta gimbal operations resume?
In fact, that's a great question. We completed the checkout expediently enough that we have resumed normal operations at this time. At the very end of the EVA was when we completed the basic checkout of the beta gimbal assembly. The engineers that were analyzing the performance of the new motor were very happy with the rates and the currents that they saw during the rotation. We rotated the beta gimbal assembly 360 degrees using the backup power feed. That BGA motor has has a redundant power feed. We used the backup power feed at first and rotated it 360 degrees. Then we switched to the primary power feed and rotated it 360 degrees, verified we had no trip conditions or no anomalous current or rate signatures. Once the engineers were happy with that data, then they gave us the green light to take the BGA back to what we call auto track mode, and that's a mode where the BGA uses the computers to track the sun automatically, and that's its normal mode of operation, and it is currently in auto track at this time.
Thanks very much. I had another question. Does anybody know why it failed? I mean, this was a pretty new, this hardware was launched not quite a year ago, And how do you find that out if you want to know? Do you have to bring it back and do a failure analysis, or would you keep it because of its size on the space station and work out some longer-term strategy to recover it?
Ultimately, we will not know for sure why the BGA motor failed until we bring it back home. Just by examining its behavior on orbit, and a number of other on-orbit tests were conducted before we replaced it, we were able to, through fault tree analysis, eliminate several possible causes of the failure. We were able to exonerate things like an electrical control unit as a possible cause of the failure. One of the things that we did accomplish on the last EVA, US EVA 13 for stage operations, is we did do a visual inspection of the BGA housing before we removed the motor. One of the things that we considered as a possibility prior to this EVA was that perhaps the motor itself was damaged by a micrometeoroid impact. The crew inspected the BGA housing on the last EVA and indicated that there were no signs of micrometeoroid impact or any other kind of visible external damage. Through that analysis, that fault tree analysis, we concluded that some kind of problem must be inside the BGA motor itself. One of the things that you could see from the video that Keith just talked to is that when you remove the old broom, to the naked eye, it looks fairly pristine. So we expect that whatever problem there is in that motor that's causing the trip conditions is somewhere inside something with some of the mechanisms inside, and ultimately we won't be able to know exactly what that is or remediate it until we get it back on the ground.
Okay, we'll go now to the Kennedy Space Center for questions.
Yes, this is Marcia Dunn of the Associated Press. When do you expect to bring the bad broom back to Earth?
I don't have that answer right away. I've heard a number of things discussed, and it'll depend entirely on the manifest, the up and down manifest for the next several shuttle flights. Obviously, it's of great interest to the ISS program management to understand the root cause of the failure of this motor as soon as practical. So I think every effort will be made to try to get it down on one of these upcoming shuttle flights within the next month or two.
Thank you. And I'm wondering if there was anything that jumped out at the engineers regarding the SARG inspection, anything that the astronauts said or saw, or any of the pictures that came down, anything that sheds new light on the problem?
Well, what we know so far, looking at the data that we have in hand, is that whatever problem we have with the SARG is not an obvious one. We did not see any additional smoking guns, as it were, as a result of our inspection today. But based on the type of damage we've seen on the race ring and some of the associated hardware, what we really believe is that what's happening is it's going to take us a detailed analysis of all of the data to really figure it out. We have not seen any obvious signs of damage to any of the key hardware, like the drive lock assembly, which actually drives the motion of the SARG. We haven't seen any significant damage to any of the other hardware that's out on the truss right now, like any of the trundle bearing assemblies that are in place right now. So in some ways, it's still a bit of a mystery for us. The engineers do have some theories, and again, it's going to take a detailed analysis of all of the data we've gotten, including a